Challenge problem on similar triangles. This is a very interesting question. Question 8. Consider the following figure. State why there are two sets of similar triangles in the given figure. Part B is find relation between PQ, PS and PR. Part C is find relation between RQ, RS and RP. Find values of the variable x and y. So side length PS and RQ. So try to solve this problem and then look into my suggestions. So we'll learn a lot of things from here. Okay, so watch this video carefully. So in this figure, what we see is there are three right triangles. One, RQP is a right triangle within which we have two other right triangles, PSQ and RSQ, right? So there are three right triangles which makes two set of similar triangles. So let's consider one by one these two sets and see how they are similar. Okay, so let's consider this small triangle PQS. Let me consider triangle PQS and the big triangle PQR. So when we are considering small triangle, I have written P, Q and S. So I will write S is the right triangle. So I have written S at the end. So I'll write PRQ. So I'll consider triangle PRQ. Now there is a logic to this. So let me explain you that logic first. When I'm trying to show that these two triangles are similar, then I have to write in a way so that their corresponding angles come in sequence. Now we know angle P is common to them, right? So angle P and P is same. So we are just checking the angles. Angle P and P are same, correct? So one angle is same, which is common, right? So this angle is common to my triangle PSQ as well as the big triangle. Now the second is the right angle, which is Q in the big triangle and S in the small triangle. Do you see that? So PQS, S is your right angle, right? So S is the right angle, and in big triangle PRQ, Q is your right angle. So these two angles are same, correct? So these are common angles and these are 90-degree angles. Now once we say these two angles are same, that means what? So in the big triangle and the small triangle if you cover, so the third angle, this angle should be equal to R. Do you see that? These two angles will be 180 minus x minus 90 or 90 minus x. So these two angles are 90 minus that angle, P, angle P, right? Not x. Now because of AA, let me say AA, that's an angle, right? The two triangles are similar. So we prove one set of similar triangles, correct? Similarly, you can prove the next set of similar triangles, and that is, now we'll write down here for the next set of similar triangles, and the next set is this triangle and the big one. So the small one here is RSQ. Since I write S in the center, which is 90 degrees for my small triangle, I will write Q in the center for the big triangle, starting with R. So triangle RQP. Do you see that? QP. Be careful in writing this. It makes sense, right? It makes a lot of sense. Now, here in these two triangles, what you notice is that angle R is common, right? Angle R is common. It is same. And angle S and angle Q are 90 degrees. So they are also same. So from AA, two angles, right? So they are similar because of angle AA property, right? So we know angle Q is 90 degrees and angle R, these are common angles, right? And these are 90 degrees, correct? Let me write like that here also. So these are common. and these are 90 degrees. And that is why this is a set of similar triangles and this is also a set of similar triangles. So we get two sets of similar triangles from these three individual triangles. Do you see that part? Correct. Now let's look into the relation between the sides for these triangles, right? Now part B is very interesting. We'll find a relation between PQ, PS and PR. So first let's write down when the triangle PQS is similar to triangle PRQ, the big one, how are their sides related, right? So let's write down the side opposite to P. In the small triangle, side opposite to P is SQ. Okay, so let me write SQ first. And in the big triangle, the side opposite to P is QR. That should be equals to, let's write down side opposite to 90 degrees. For small triangle, it is PQ. For big triangle, it is PR, correct? And now the third angle. For the small one, it is PS. And for the big one, it is PQ, correct? So that is how the sides are related for these two triangles which are similar, right? Now we need to find relation between PQ, PRS and PS. Let's consider this equation, right? Now here if you cross multiply, what do you get? PQ times PQ is PQ square. Do you see that? So we get PQ square is equals to PS times PR. Do you see that? PS times PR. This is extremely important relation which we have just developed. So PQ square, so that means hypotenuse of the small triangle, PQ square is equal to product of PS and PR. Do you see that? PQ square is equals to product of PS and PR. So that is a relation which we got here. Well, we can always find X with this relation for sure, right? So we'll do it later, but let's find now relation how RQ, RS and RP are related in this triangle, right? Watch it very carefully. It is extremely important question to understand under this heading of similar triangles. Now we are considering the triangle RSQ, that means RSQ, the other small right triangle, with the big triangle RQP, right? The big right angle triangle. So both are right angle triangles and both of them are similar. So let's figure out how are their sides related. Okay, so we can consider with side opposite to, let us say, so common angle R. Okay, let's start with R. Now in the small triangle, side opposite to R is SQ, right? We write SQ, and side opposite to R in the big triangle is PQ, correct? Now side opposite to right angles in small triangle is RQ. Side opposite to 90 degrees in big is RP. And now let's consider this angle in the small triangle. So this angle is the third angle. So third angle side opposite is RS. Divided by here, this is the third angle, is RQ. That is the side opposite to this triangle, correct? Now from here, you get a similar relationship, right? If I multiply RQ and RQ, I get RQ square. That is RQ square. The hypotenuse of the small right triangle is equal to RS times RP. Do you see that? When we cross multiply, RS times RP. So we get very similar relation. Do you see that? That is how they are related. And let me write down this relation right on the top for you, right? So what we get here is RQ square. Let me write down here. RQ square, that means this side, is equal to product of RS and RP. Do you see? It's product of RS and RP. So that is an interesting relation which we get, correct, for these triangles. Now the last part is finding variable x and y. So you can use these relations. PQ we know is 6, right? And PS is not known to us, which is x, and PR is x plus 9, right? So we can use this and find the value of x, correct? Or even otherwise, you can use one of these ratios and find the value of x. Similarly, you can use one of these ratios and find the value of y, correct? So I'll leave that part to you. Solve this. So here what we learned today is that hypotenuse of the small triangle, square of that, is equal to product of the sides RS times RP. Similarly, we found that PQ square is equals to PS times PR. Do you see? That is kind of a very interesting relation which we found. Now, to find the values of x and y, I'm just leaving it for you. It's a simple calculation which I expect you to do and which we did in the previous question, right? Question 7. So I'm not doing it here, right? So do it yourself, get your answer, okay? Thank you and all the best.